Okay, so one of the big themes in Unit 4 is energy. Okay, the title is called Global Systems and Energy. So we've just had this unit that's been all about energy. Okay, thermal energy, mechanical energy, all that kind of stuff. What we're going to look at here is why the Earth works the way it does in terms of energy. Transfers of energy, this would be mostly thermal energy now, so heat. Okay, and motion of the Earth, and energy inputs and all that kind of stuff. Kind of how the Earth works in terms of energy as a big system. Okay, so that's what we're going to be looking at in this unit. So we'll start with the thing that most exemplifies or best shows that energy, and that is climate. Okay, so first thing we have to know, what is climate? Okay, and then we have to look at the 4 components of climate. Okay, it will be important for you to know. They are something you do have to memorize, the 4 components of climate. Okay, so the 4 components of climate, 3 of them are pretty obvious. The 4th one, not always so much, but it's important. Okay, so I want you to think about this. In the morning, you take out your phone, okay, and you see you got like 200 snaps from the night before while you were sleeping from your friends, okay? And then you're like, oh, I got to check the weather, so I know whether I need a coat, or whether I should wear shorts, or whether I should have an umbrella, or because we live in Alberta, you just bring them all, because if we don't like the weather, we wait 5 minutes, okay? So you check the weather, and there's a few things you want to know. First off, you want to know the temperature, okay? That's the first component of climate. Okay, is temperature. Is it going to be warm today? Is it going to be cold today? Okay, temperature is a big one. Second thing you want to know, is it going to rain, snow, hail, sleet? We live in Alberta, all of them, okay, in one day. Okay, I got to be prepared. Do I need my umbrella or raincoat, whatever? Okay. Third thing, wind. Okay, are we getting a Chinook today? Is it going to blow 120 kilometers an hour? Okay, I definitely don't want my umbrella if it's going to do that, or my umbrella will be trash. Okay, so wind, okay, an important one. Here's the one that people don't think about. Light. Okay, we don't think about that as much, but it's an important part of climate, because here, light changes a lot throughout the year. Okay, right now, we're approaching the summer solstice on June 21st, okay, where we will get the longest day of the year, okay, or the most hours of sunlight. Obviously, all days are the same length, okay, but we'll get the most hours of sunlight on that day, okay, because here in Canada, we experience light a little differently than someone who lives at the equator. If you live at the equator, does your length of day change? Not significantly, a couple minutes. Okay, June 21st, you get a couple minutes more sunlight than you do on December 21st. Here, on June 21st, we get 18 and a bit hours of sunlight, and on December 21st, we get 6.5 hours of sunlight. Okay, it's different. Okay, and light affects a lot of things. Okay, it affects how much energy is available. Okay, it's pretty important, but it's not one we think about. But believe it or not, it is one of the things that's on the first page of your weather app. Okay, it tells you when the sun is going to come up, when it's going to set, whether it's going to be cloudy or not. Okay, all of that is about light. Okay. All right, so those are the 4 components of climate. We are going to look at the factors that affect that. So when we describe our climate, we're going to talk about those 4 things. But the way those 4 things are in this particular place is a result of factors that affect climate. Okay, things that go on that make us have different length of day, or lots of wind, or rain or not, okay, that kind of stuff. We're going to look at those factors. In the end, this is what I'm going to want you to be able to do. On your unit exam, I'm going to put a map of Canada on there, and I'm going to pick a city, okay, and I'm going to point to that city, all right, in case you don't know your geography and you don't know, where Winnipeg is or something. Okay, so I'll put an arrow that says this city right here. Right? And I'm going to ask you, describe what you think the climate of this city would be like by talking about the factors that affect its climate. So if I picked, like Tuktoyaktuk, okay, way up in Nunavut, Okay, and I said, what's the climate of this going to be like? You would tell me it's going to be really cold because it's very far from the equator. It has a very high latitude. Okay, this results in its length of day being significantly different between summer and winter. In fact, it's high enough up there that it's in the Arctic Circle, and on June, for a few weeks around the 21st of June, the sun wouldn't set. And for a few weeks around December 21st, the sun wouldn't come up. Okay. It's going to be probably pretty dry up there because of the locations of high and low pressure. This is stuff you guys don't know yet, but that's what I would be looking for you to tell me. Here's the things that are going to affect that place based on where it is. Here's what I think its climate will be like because of that. So you can kind of have that in your head as an idea of what you need to get out of today's lesson. Okay. Number 3 and number 4 we kind of just touch on a little bit. They're not terribly important. Okay. And then number 5, create and understand climatograms or climate graphs. We are going to be doing quite a bit with those. Okay. Being able to look at a climate graph and determine, okay, the climate of this area is like this. Here's where it's likely located, and here are the main factors that would affect it. Okay. All right. So in this picture here, okay. Definition of climate. Definition of climate is the prevailing weather conditions at a location. The prevailing weather. It is, of course, day to day, right? Describing the climate of an area does not mean giving me the averages for that area. Okay, here's what I mean by that. If I was to describe the climate of Okotoks, okay, based on the averages, this is what it would sound like. In Okotoks, the temperature is 5 degrees Celsius. There will be about 1 millimeter of rain or snow, okay, or hail. There will be 1 millimeter of precipitation. The wind will come from the southwest at 35 kilometers per hour, and there will be 12 hours of day and 12 hours of night. Is that an accurate description of the climate of Okotoks? Absolutely not. That's the averages, okay? But that doesn't tell me what the climate of Okotoks is like. Okay? Today, okay, around the end of May in Okotoks, we could expect that it's probably going to be in the mid to high teens. Okay, it's probably going to be sunny, but there will be a lot of humidity, and there could be a possibility of a thunderstorm. And the wind will likely be out of the southwest, okay, at about 20 kilometers per hour, okay, something along those lines. That's climate. What is the weather going to be like in that place at a particular time? Okay, everyone follow me there? Okay, that's why the definition of climate change, okay, is if you see a significant or trending change for that particular climate, okay, over time, right? Climate change is not something that we can say from like morning to afternoon. You don't witness climate change between 9 a.m. and 2 in the afternoon, okay? Only Leonardo DiCaprio thinks that, okay? I like to bash him during this lesson, okay? Because he bashed all of us Albertans one time when he was filming The Revenant here, okay? He's kind of an activist, or likes to think of himself as one, which that's fine, okay? But you got to get your facts straight, otherwise you just look stupid. And this day, Leonardo DiCaprio was made to look pretty stupid by us Albertans, okay? Because a Chinook came along. So 9 a.m., he's filming The Revenant, it's minus 20 degrees, okay? It's a typical February day, and we get a Chinook. Well, by 2 in the afternoon, actually by noon, it was 14 degrees Celsius, and it was sunny, and the wind was blowing at 100 kilometers an hour, and he tweets out, "I witnessed climate change firsthand in Calgary, Alberta today. The temperature went from minus 20 to 14. The world is going to end because of all the bad things going on here." Well, Alberta quickly took to Twitter to respond, okay, as that is how Twitter works, I guess. Okay, and they're like, dude, get your facts straight. It's called weather. Climate change is something that happens over time. And yes, it's happening and it's a real thing, okay? But it happens over hundreds of years. You didn't witness it in 4 hours. It's called a Chinook. Look it up, doofus. Okay, like, yeah, it was, and he got like torn apart because he was trying to make a statement and, you know, whatever his political ends were, okay? But in the end, he was totally wrong. That's Chinook. We see that all the time, right? It's like in Alberta, it's like, you can't have all 4 seasons in one day. Alberta, hold my beer. Okay, like, sure we can. Okay, it happens all the time here, right? But he was obviously wrong about that. There's knowing the definition of things so that you get things right and you don't look silly. All right, so prevailing weather conditions at a location is climate, okay? And that is from time to time, right? I would describe the climate of Okotoks in December much differently than I would describe it today. All right, so major components we already said: temperature, precipitation, light, and wind. What's going on in this picture? Think back to grade 5 science. What kind of cloud is that? It's kind of a long name. Cumulonimbus. Okay, that is a thunderhead. We get them all the time here. Okay, we live in the Tornado Alley of Canada. I'll explain to you why. Okay, a little bit later when we're talking about factors affecting climate. Okay, so in order for a thunderhead, cumulonimbus cloud, to build, for us to get a thunderstorm, certain conditions have to be present. Okay, thunderstorms are part of our climate. The conditions here are favorable for their formation, quite often between May and August, really. Okay, in order to get one, you've got to have a fair amount of sunshine. That's the energy that causes them to build. We don't get them in December because there's not enough energy to build one. Okay, there's got to be a fair amount of moisture. We need the humidity. Otherwise, where does the precipitation come from? The water's got to come from somewhere, so it's got to be fairly humid. Okay, it can't be super windy. If it's windy, okay, then the cloud formation can be disrupted because the air is moving and you don't get the right pattern of air movement. Okay, so these components of climate have to work in a certain way. Okay, you also see those components of climate work in a similar way in the Tornado Alley, the real Tornado Alley. That's, you know, like Iowa, Oklahoma, and Kansas. Okay, they're in the mid-latitude states. Okay, they have similar conditions: longer days, lots of heat, lots of humidity. These things build. Okay, now in a thunderstorm, what's going on, okay, is you've got warm, moist air, and it's moving upwards, as you know, warm air tends to do. Come on, in the pen. Okay, so it starts to move upwards, and it actually moves upwards very quickly, okay, and with a fair amount of force. Thank you. Yeah, and change that. Okay, so it moves upwards with a fair amount of force. Okay, you got all this heavy, moist air moving up. Okay, and that continues to go on throughout the day. But as moisture moves higher in altitude, what happens to the temperature? It goes down, right? It gets colder up the higher you go. Okay, so some of that water vapor is going to condense and it's going to turn back into liquid water, little raindrops. Okay, and those little raindrops want to fall back down because of gravity. Okay, but in a thunderstorm, the warm, moist air moving upwards is so strong that water droplets try to fall, but they get forced back up by the warm, moist air that's moving up. Okay? Now, the more they get pushed up, because they're cooler, more moisture will condense onto those raindrops, making the raindrops get bigger and bigger. So if you get like a little mild thunderstorm, right, you get some raindrops, they're not terribly big, you can probably walk between them. Okay? But as the thunderstorm gets more and more severe, the raindrops become bigger and bigger. Okay? Now, there comes a point where if those raindrops have gone through this cycle, okay, the more they go through the cycle, the taller the cloud gets. Well, eventually, if that raindrop has gone through that cycle enough times, and all of this is below the freezing point of water, the raindrops will freeze and will turn into hail. Okay? Now, hail does the same thing. If there's enough updraft force from warm, moist air, hailstones, which can be fairly large, okay, can get pushed back up. Now, the hailstones are cold, they're ice. So the water vapor condenses onto the hailstone, making the hailstone get bigger and bigger. All right? The next time we get hail, don't go outside. Okay? Wait till the hail is done. And if it's decent sized hail, go out and get one of the hailstones and hit it with a hammer. Okay? You'll see layers like an onion on the inside. You'll be able to count how many times that hailstone went through the cycle inside that storm cloud. Okay? Every time it goes through the cycle, another layer of ice will be formed on the outside of it. Okay? So if you get golf ball sized hail, which is reasonably common around here. Okay? You always see that car in the parking lot, that looked like somebody, chimpanzee went crazy with a ball peen hammer. Okay? So you look at a hailstone the size of a golf ball, and it's going to have probably 5 layers, maybe a half a dozen, 6 layers, right? If you see a hailstone that's bigger than that, if you had like a baseball-sized hailstone, it would probably have 10 to 12 layers in it. Okay, softball-sized hail, not common, but it happens. Okay, you'd probably be looking at 18 layers, 20 layers. Okay, largest hailstone ever recovered had 3.8 something liters of water in it. It was literally the size of an ice cream pail. Okay, so imagine that. Okay? You wouldn't want to be out in that hailstone. Okay? Like that, those would break through your roof. Take shelter in your tornado shelter for that one. Okay, obviously that's like an extreme circumstance, but okay, we've had softball-sized hail in Alberta more than once. Okay, they had it in Wainwright in 2002, I think it was. And every car dealership in the town had their entire inventory destroyed. It wasn't just the windows, the brand new cars, and they were written off for parts. Okay, because softball-sized hail is bad. All right, is that making some sense? Okay, so all those components of climate work together to produce different climates in different places. Now, those components of climate are affected by factors. So we need to know the 4 components, and then we need to know the factors that can affect them. Okay? The number 1 factor affecting the climate of any given location on Earth is latitude. Where you are on Earth in relation to the equator is the number 1 factor affecting your climate. Because the farther away from the equator you get, the colder it's going to be, generally speaking. Okay? Here's why. At the equator, the sun is directly overhead. Okay? So all of these lines here represent equal amounts of solar energy coming from the sun. Okay? At the equator, that amount of solar energy hits an area the length of that red line I just drew. Now, as you move away from the equator, because the Earth is round, P.S., the world is round, okay, that same amount of light is now over a larger area. So same amount of energy, but now it's spread out over a bigger area. That means it's less intense. And then you have less energy per square meter striking the Earth. That means it's going to be colder. Okay, it gets worse the further from the equator you get. Okay, when you get up to here, where we are, that same amount of sunlight is covering an area almost twice as large. Okay, meaning it's half as intense. Okay, everyone all right with that? Now, this effect is exacerbated by the fact that the Earth is tilted. Okay? So the Earth's axis is tilted 23.5 degrees. It is actually why we have seasons. Okay? If the Earth was perfectly straight up and down, we wouldn't get seasons. Okay? We get seasons because of the tilt of the Earth. Here's how it works, in case you didn't know. Okay? So that's the sun. This is the Earth's orbit, not drawn to scale. Okay? Here's the Earth. So this is the Earth on June 21st. Okay? June 21st is the summer solstice. Is the summer solstice. That is the longest day of the year for us. Okay? The reason it's the longest day of the year is because the Earth, the North Pole, is tilted towards the sun. So as the Earth rotates this way, we stay in the sun for longer. If you're in the Arctic Circle, the sun doesn't set. Okay, everyone kind of follow me there, right? Because the North Pole is tilted towards the sun and the Earth rotates on its axis. That part of the Earth never gets into the shade. It just stays in the sun. Okay? On the summer solstice, if you're in the Arctic Circle, the sun does this overhead. Okay? It moves in a circle, literally. Okay? It does not set. In fact, there's about a 4 to 6 week period where the sun doesn't set. If you're a little kid and your mom says, come home at dark, you come home a month later. Okay? Like it's literally that extreme. Okay? For us, yeah, we get like 18 and a half hours of sun because we're going around and around like this, but we are only in the dark for this much of the total spin. Okay? So we get longer days. Now, if we're tilted towards the sun, that means that this diagram tilts this way. And we're now more like this instead of this. So not only are we getting more light, we're getting more intense light. So more energy. Why summer is warmer than winter. Okay, does that make sense? All right. So as the Earth goes around, okay, this here would be September 21st. What do we call that? The autumn starts with E. Equinox. Right. Okay. On the autumn equinox, the way, whoop, I drew the axis the wrong way. Shame on me. That's terrible. Okay, the axis should look like that, okay, because the axis doesn't change. Okay, September 21st, okay, we get 12 hours of sun and 12 hours of night. Okay, because the Earth's axis is like tilted so that it's parallel, basically. Okay, and then on December 21st, okay, we get the winter solstice, shortest day of the year. Okay, because now the North Pole is tilted away from the sun, so when the Earth rotates like this, we only get in the sun for that much of the orbit. Okay, it's the opposite of June 21st. Okay, at the North Pole, the sun doesn't come up. And so if you ever use that expression, don't worry, the sun will come up tomorrow. It's not true. Okay, if you're in the Arctic Circle in December, the sun will not come up tomorrow. It'll come up in a month. Okay, they call those the dark days up there. Okay, seasonal affective disorder is a real thing. Okay, when you actually never see the sun for a month. Okay, and then down here, okay, this would be March 21st. Okay, it would be the spring or vernal equinox. Okay, and so as the Earth goes around, the effect of latitude is exaggerated. Okay, because we get more intense sunshine. Does that make sense? Okay. So if I gave you that question I was describing, I picked a city in Canada, okay, and I said, tell me what the climate would be like here, pick latitude. You can pick latitude no matter what city I pick, because latitude affects your climate. You can just say, this city is, if I picked Cairo, you could say, Cairo sits right on the equator, so its amount of sunlight would be very intense and it would receive the same amount all year long, okay, giving it basically no seasons. That would be a good description. Okay? If I picked Winnipeg, well, then you would say what we just said here. Okay? The amount of light is going to change because its latitude is very high and blah, blah, blah. Does everyone kind of follow? Okay, so latitude's a big one. The biggest one. That's why it's first. Okay, second biggest one. Altitude. Okay? I mean, we see the mountains all the time here. Okay? We know that snow stays on them longer than it stays here. Okay, hopefully, there's snow on those mountains into July. Okay, last year there was no snow on the mountains in May, and we had all the fires and all of that stuff. Okay, if we can keep snow on the mountains till later, like we usually do, okay, that's good for us. But the snow stays there because for every 1,000 meters you increase your altitude, you increase about decrease about 6.5 degrees in temperature. Okay. And you can experience this if you go hiking in the mountains. Now, I'm a little bit embarrassed to say that I did take this picture before you were born, okay, and I'm still using it. But it's a good example. Okay, so on this particular day, this is Mount Robson, and it's the highest peak in the Canadian Rockies. It's like, I want to say it's like 8,000 meters or something like that. It's very tall. Okay. So when we started our day, we would have been like down by the plug-in down there, okay, at an altitude of about 1,400 meters. It was, let's say, about 12 degrees Celsius and it was raining. Okay? We hiked up into this pass. which is about 2,300 meters, it was starting to snow. The rain had turned to snow. Okay? We've gone up 1,000 meters and the temperature had dropped, okay, more than, well, about 10 degrees. Okay? We've gone up about 1,000 meters. Okay? The rain was turning to snow. What was going on top of the mountain? Can you see the top of the mountain very well? Because on top of the mountain, it was -20 and blizzarding. Now, these places, like on the map of the Earth, are all within 10 kilometers of each other. Okay? We walked 14 kilometers to get to this, and a lot of that was like back and forth on switchbacks up a hill. Okay? These two places are not far apart geographically, but they are far apart vertically. Okay? And so the people that were trying to summit that day didn't succeed because the conditions near the peak were that you couldn't see your hand in front of your face because of all the snow, and it was -20, even though this was the 8th of July. Okay? So altitude definitely affects your climate. Okay? It's why, well, one of the reasons why Calgary is colder than Vancouver. There's more than just one reason, but it's one of the reasons. Okay? Vancouver has an altitude of 0. It's at sea level. We have an altitude of 1,096 meters. We are more than 1 vertical kilometer higher in Calgary and Okotoks, okay, than Vancouver. Okay? Makes a big difference. Okay? It's colder the higher you go. Everybody good with that? Okay. Okay. Distribution of land and sea. I'm going to come back to Calgary versus Vancouver a whole bunch here, okay, as we're talking about these. Being next to the ocean has a big effect on your climate, okay, because of the second law of thermodynamics. Okay? Here in Okotoks, we don't have any big bodies of water. Okay? So if the air temperature drops, there's nothing to regulate it. It's just going to drop. If you live in Vancouver, if the air temperature tries to go down, it can't go below what? It can't go below 0. Because once it gets to around 0, the water is warmer than the air. And energy will come out of the water and warm the air. So being next to the ocean can regulate extreme changes in temperature. Okay? Vancouver, most of the time, doesn't get below 0. Okay? And most of the time also, it doesn't get more than 25 degrees. Okay? There's just this balance that is achieved there because it's next to a big heat sink. Okay? The ocean. Right? The ocean can regulate your temperature. Now, a big part of that is also where is the water in the ocean coming from? Okay? There are ocean currents that can affect the temperature of the water, which can then affect your temperature. Okay, we'll talk about that here next. Okay, that would be the nature of ocean currents. Now, being next to the ocean can mean that you also get a lot of rain. It doesn't always, but it can. Okay, after all, the ocean is full of water, in case you didn't know that. Okay, thanks, Captain Obvious. Okay, but it is a source of a lot of humidity and moisture. Okay. And in Canada, we're talking about Vancouver, the prevailing winds bring moisture off the water and onto the land. Okay, so that's the effect of being close to the ocean. It can increase your rainfall, doesn't always, but it can. But it does regulate temperature because it has the ability to hold or give off energy. Okay. Now, the next one is ocean currents. Okay, so the oceans, they don't just sit still. Okay, they're not just big, bathtubs that are, the water just stays put. They're circulating all the time. There's all kinds of different currents within the ocean. Okay, here in Canada, at least on the west coast, okay, we're influenced mostly by the California current. Now, the California current is produced in part by the interaction of the Alaskan current and the North Pacific current. The North Pacific current actually brings warm water from equatorial areas, so it's a warm current. But when it gets to here, it's near all that ice, okay, and so it causes a circulation of warm to cold, second law of thermodynamics going on there, okay, and what ends up coming off of it is the California current, which is cold water coming out of the Arctic, okay, up here by Alaska. That's why you can always tell Canadians, okay, if you go to Mexico or someplace tropical, you can always tell who the Canadians are. They're the ones who approach the ocean with trepidation. Like this, because we just always expect water to be cold, because we live in Canada, the ocean is cold, lakes are cold, okay? We just don't, we approach it like it should be cold, okay? So we got this cold water going by the west coast, okay? If you've ever been to the west coast, you know the ocean there is cold. People that surf, they wear wetsuits because it's that cold, okay? We got this cold water here, but it still allows moisture to move onto the land, okay? And still regulates the temperature. It's still liquid, so it's still above zero, okay? On the other side of Canada, okay, on the east coast of the United States especially, okay, they're influenced by very different currents. Their currents come from the equator and then go north. So they're always bringing warm water. Okay? It's why you never see a hurricane over here tracking like this, but you see them all the time here. Okay? This is where hurricanes happen. Okay? And it's because there's all this warm water. Warm water has lots of energy. It's how you build a hurricane. You don't build a hurricane with cold water. Okay? So you've got this warm water, okay? The north equatorial current, the Gulf Stream especially. The Gulf Stream is mostly responsible for hurricane formation. Okay? So the hurricanes always come in this way. They go across all the Caribbean islands here, and then they go up the eastern coast of the United States. You almost never get a hurricane in Newfoundland. Occasionally you might get the tail end of one, but most of the time, by the time that thing gets there, it's no longer a hurricane. It's a tropical storm, okay? It's degraded. Why? Loses energy to the land, and what happens to the temperature of the water? It gets colder. Okay? You need the warm water near the equator and here in the Caribbean to build the storm. If you start getting colder water, the storm dies because it doesn't have the energy to keep going. Okay? So depending on your latitude, again, okay, you might be influenced by hurricanes or not. Okay? Your ocean currents may or may not bring that kind of weather to you. Okay? So all of those things can affect your weather. Okay? Everybody all right with that? Okay, now, has anyone been to the East Coast in the wintertime? Okay. The East Coast in the wintertime is a very different experience than the West Coast in the wintertime. Okay? And that's because, again, this California current, while we say it's cold, is nothing like the Labrador current. Okay? The Labrador current comes out of the Arctic Ocean. It is brutally cold. That's why winter in Newfoundland is much different than weather, okay, across the way, same latitude in Vancouver. Okay? Same latitude, same altitude, okay? But winter in Newfoundland is very different because of the ocean currents. Okay? Everyone all right with that? Okay, this one affects us. Okay? If I was to give you that question and I listed Okotoks, okay, as the city I wanted you to describe, okay, this would be one of the things you would talk about. You'd say latitude, you'd probably say altitude, and then mountain barriers would be the next thing. Okay? The Rocky Mountains influence our climate in a massive way. Okay? Because they cause a rain shadow. Okay? So what happens with a rain shadow is, like, if we're talking about the west coast of Canada, so Vancouver, Victoria, okay, there's, we got the ocean water, it's evaporating, and the winds push it onto the mountains. Well, you've got all this warm, moist air coming off the Pacific, okay, and it hits the mountains. And when it hits the mountains, it has to go up. What's going to happen to the moisture is that air goes up. It's going to get colder. It's going to condense, okay? And so what you end up with is what we call the rainy windward slope. It's why western BC has a temperate rainforest. Okay, like, I don't know how many of you have seen, like, The Return of the Jedi. Okay, they filmed the last scenes with the Ewoks in, like, Vancouver, right, with all those giant sequoias that were like these huge, massive trees. Okay, they can get that there because they get tons of rain and they get a fairly regular climate because they're close to the ocean. Okay, so all of that rain, all the precipitation, that moisture from the Pacific falls on this side of the mountains, creating dry conditions behind, or what we call a rain shadow. Okay? The rain doesn't get over the mountains, okay, because the mountains make it fall on this side. Now, once you get to here, you've lost all that moisture. Now you've got cold, dry air sitting on top of a mountain, being pushed from the west. Right? So, is cold air more dense than warm air? It is. So more dense stuff wants to fall. So this cold, dry air falls down our side of the mountains, what we call the east slopes. Okay? As it falls down this side, it rubs against the mountains. Okay? It's called friction. What does friction produce? Heat. Okay, so you got this cold, dry air coming down the side of the mountains. There's friction there, it's heating up, and it's falling, so it's gaining speed. Okay, and it's going to come whipping off those mountains as a Chinook. Okay, guys, Chinooks are a highly localized phenomenon. Okay, in Leonardo DiCaprio's defense, that's why he didn't know about them. Okay, if you go even to Newfoundland or Nova Scotia and you talk about a Chinook, they'll look at you and go, what? What is that? What language is that? Okay, they're not going to know. Chinooks only happen in places like Alberta or in the Gobi Desert, okay, in Asia. Okay, they're a very localized phenomenon that is caused by the rain shadow of a mountain. Okay, so we get them here. They're common here. We know about them, but we go somewhere else. Okay, we won't know about them. Right? Like Dan, did you ever heard of a Chinook before you got here? Right? It's not something that happens everywhere. It's a very local phenomenon, and it's caused by this. Okay, that's why we say mountain barriers can affect your climate. They can create dry conditions on one side, wet conditions on another. Okay, rain shadow. Okay, Chinooks, all of that. So what you see here, guys, these white things here, those are the Himalayas. Okay, now the Himalayas are like 3 times higher than the Rockies, right? On one side, you've got tropical rainforest. On the other side, you have a cold, high-altitude desert called the Gobi Desert. I think it's in Mongolia. Okay? But the Himalayas produce this huge rain shadow behind them because they're so tall. Okay? All right, everybody okay with distribution of mountain barriers? Okay, so mountain barriers are huge. Okay, they're a huge effect on climate. So if I was to, point at, I don't know, Sault Ste. Marie, Ontario. Would you list mountain barriers as a factor that affects climate there? No. Okay, but if I picked Lethbridge, you definitely would. All right, the last 2, patterns of prevailing winds. Okay, where your winds come from, okay, usually that's going to bring you a certain consistent weather. Here, wind typically comes from the southwest, and it usually brings, warm, dry air, right? If the wind shifts and it comes from the northeast, we know we're in for something, okay? But typically, we get the weather we get because of the direction the winds come from prevailingly. Now, the last one, I get to act like a meteorologist on TV. I have my weather map and I'm going to draw on it and do stuff. So, centers of high and low pressure. There are certain places on Earth that are like always low barometric pressure. That usually means cloudy and rainy. Okay? And places that are high barometric pressure. That usually means clear skies. Could be warm or cold. Okay? We know in the wintertime, if we get a high pressure area here, that's those days where you look outside and you're like, oh man, the sun is out. And you go outside and the air slaps you in the face. Okay? Because it's minus 40. Right? So high pressure usually means dry and clear. Okay? Low pressure usually means cloudy and wet. So right here, oh, that's a terrible color to use. And right here is what meteorologists call the mother low. It's almost always low pressure there. Okay? This is Fort St. John, BC. It's the wettest place in Canada by a huge amount. Okay? Now, around the mother low, around any low, circulation is clockwise. So air circulates like this, and air masses, moist air masses, can be thrown this direction, that direction, or this direction. Okay? So anything that comes off of the mother low is going to have lots of precipitation, lots of moisture. Okay? Right here is the Siberian high. Circulation around a high is counterclockwise, the opposite. this is always going to have cold, dry air. Every once in a while, this will throw off an air mass, and this will throw off an air mass, and look where they meet. Right down Highway 2. Okay? This is why in the winter, any storm that tracks through here follows that path. Okay? That's the tornado alley of Alberta, of Canada. Okay? The conditions of unstable interaction of air between these two air masses leads to unstable wind. Okay? And so we get blizzards, horrible snowstorms in the winter, big thunderstorms building in the summertime, okay? And always right in our backyard, right down Highway 2. Okay? Red Deer to Airdrie area is like the worst. Okay? All right. We will talk about climatograms just briefly here, guys. Okay? And then we'll pick up with them again tomorrow. But so a climatogram doesn't show you all the 4 components of climate. Okay? It only shows you temperature and precipitation. But it shows it by month. So you can draw some conclusions about where this place is and what factors might affect its climate, which is something I'm going to ask you to do. Okay? I give you a climatogram, you first interpret what it's telling you, and then give me an idea of where you think it is and what factors might make the climate the way it is. All right, so in this first climate graph, we've got, the green line is the temperature line. The bars measure precipitation. What do you notice about the temperature in this area? Stays consistent. Where on Earth is this? Close to the equator. In fact, Mount Quarry sits on the equator. Okay? So their temperature doesn't change because the amount of sun they receive is constant. Okay? So even though the climatogram doesn't tell us that, we can infer that from the shape. We can say, oh, one of the main factors affecting this climate is that it's on the equator. Okay? Now, if you look at the rainfall, that's the bars. Is this a pretty wet place? Yeah, the driest month, they get 11 centimeters of rain. Okay, that's like the wettest month here. Okay, that's a lot. Right? If we get a good June, that's usually our wettest month, we might get 10 centimeters, okay, of rain. Right, so that's a lot. That's their driest month. So yeah, this is going to be a tropical rainforest. They have a wet season and a dry season. Okay, but because it does fluctuate. Now, the next climatogram, look how the temperature line changes. Okay, is this further from the equator? Yes, because this place has seasons. Right? This place doesn't have summer, winter, fall, and spring. Okay, this place does. Right? Now, we always joke around about how we don't have spring or fall here, that we abruptly shift from summer to winter and winter to summer, but we still get this bell curve. Okay? If you see that bell curve, you know you're talking about a place that's further from the equator. Now, the further you get from the equator, the lower the bell curve will go. Okay? This is Nashville, Tennessee, mid-latitude United States. This is Anchorage, Alaska. That bell curve is shifted considerably lower. Right? These are the things we can infer from the climate graph. Eventually, what I want you to be able to do is, if I give you a climate graph, you tell me what biome it fits with and why. We'll talk about biomes later. Okay? So we'll pick up with that. I'll talk a little bit more about that tomorrow. Okay? And then we'll talk about energy transfers. Okay? Good job today, guys.